As I told you at the very beginning of this set of presentations, the business methodology is based on an expert-based approach. That means that Visus tries to reproduce the expert reasoning approach when applied on data acquired by external surveyor, not by the expert itself. We will see how Visus uses this approach in its methodology. I just want to show some slides that answer to the question what to evaluate and which are the main safety issues to assess for the multi-hazard safety assessment. We will see that we can just group the safety issues in 5 main groups that we will discover through an example focused on seismic case, but that can be applied on other hazards or also an ordinary use case. First of all, I want to show you this picture of 2 houses. Well, you can see just one house and a set of rubbles on the right side. This picture comes from our survey conducted in Italy after the earthquake of magnitude 6.3 in 2009. You can see that the 2 houses, one close to the other, show very different behavior after the earthquake. The house to the left is quite intact, while the house to the right is completely destroyed. So, after an earthquake, school buildings can completely collapse. So the structure can completely collapse, as you can see from this picture from an Indonesia ITB database. This picture, you can see there are some elements still standing, but there is a complete collapse of the structure. This picture is already was acquired in Italy after the L'Aquila earthquake. And here you can see a building, but if you look carefully, you see that the first floor, the ground floor of these buildings, completely disappeared. There can be also local collapses due to earthquake. Here you can see a portion of a wall that collapsed, but there can be also the collapse of non-structural elements. This picture was acquired by the researchers of the Sprint Laboratory in Udine. Is inside the post office, and you can see that all the non-structural elements fall, and you can just imagine how could be being inside this building during a seismic event. Similarly, these pictures are acquired from Indonesia database. These are of schools, and you can see the non-structural elements could fall on children and cause death or injuries. Also, portions of non-structural walls that are non-structural elements can fall. Here you can see that the structure didn't collapse, but the non-load-bearing walls completely collapse, and you can just imagine how the situation is inside this building. The collapse of non-structural elements, or structural elements, can also create problems for the during the egress from that building in case of an emergency. This is a case in after an Italian earthquake, and here you can see how difficult, even if impossible, is to go outside from this building because the stairs are completely occupied by non-structural elements. Also in this case of the schools, the fall of non-structural elements stops and blocks the egress of people, and so this is an issue for occupants of the schools. Last, you can see here that this was a place where a building was located, but there were a landslide, and the site is not more available, and the structure collapsed with the site. So we have seen that there are different issues, different aspects to investigate in order to assess the safety of a school complex. So we need to have a 360 degrees evaluation of the problem in order to assess the safety. We need to assess the structural global problems concerning the entire structure. We need to assess the structural local problems, so local faults of the structure. We need to assess the non-structural problems that could also in this case create problems, death or injuries to the persons in the school or outside the schools that can be affected by this. We need to assess the functional issues, considering the problems that local faults of structural and non-structural elements could cause on the egress path from the building to a safe area. And finally, it is important also to assess the site problems, because the location where the school is positioned should be safe and not create safety problems, for example, because of rock falls or landslides.